Hi, I'm Gabe Johansson, co-owner of Live Nutritious Fitness, and today I'm here with Nate Darnell, research analyst for Diabetes Support Services, to ask a few questions about electrolyzed water. Good morning, Nate.
Good morning, Gabe.
Nate, first question I had for you is there's a lot of talk about how much water we should drink. I've seen people say you should have 2 gallons of water a day. I've seen people say you should have 4 glasses of water a day. What's your take on that?
Yeah, that's a really good question, and it's not so much my personal take so much as it is kind of a scientific consensus. And I've seen, as a research analyst, I see extremes on both sides. I see physicians that have an extreme opinion that we should be drinking more than that, and other physicians and scientists saying, no, we don't need that much. What we do know is that in 2004, the National Academy of Sciences really put a bunch of scientists to task, and they looked at a whole bunch of data, and it was even difficult for them to say how much we should really be consuming per day, because there are so many differences between human beings, based on size and whether or not they're engaged in a lot of athletics or not. But they pinned down some averages, and they said, for the average woman, she should be consuming about 2.7 liters of water per day. For the average man, about 3.4 liters of water per day. And when we're looking at, how can we translate that into, everyday, kind of measurements and terms, 1 liter is the equivalent of 4 glasses. 2 liters is the equivalent of 8 glasses. So of course, 3 liters would be approximately 12 glasses of water. So one of the other things is that we get a lot of our hydration from fruits and vegetables too, so long as we're eating a really healthy diet. So that doesn't mean you need to consume 3 liters of water or close to 3 liters of water. It simply means that's the recommended daily consumption. As long as we're eating a really healthy diet, we should be getting a lot of that from our fruits and vegetables.
Okay. So when it comes to electrolyzed water, there's a lot of talk about demineralized water and reverse osmosis. If an athlete or anybody is drinking demineralized water, what does that do to your body?
And that's another really good question. And I think before we even talk about that, I've seen some extreme examples of like overhydration, where I've seen kind of pseudo health professionals say, well, we should just drink water to our heart's content, and that's a very dangerous thing to do. Water can be just as toxic to us, in great amounts as not having enough. And we know, for instance, it's one of like the 3 basic things we need for survival, right? If we don't have air for 5 minutes, we're going to perish. If we don't have water for several days, we're going to perish. If we don't have food, we'll perish after about 30 days. We can go for a while without food. But water is a critical need. At the same time, human kidneys can only filter out 1 liter per hour. So consuming significant amounts of water in short order, it can be hazardous. And the body has to do something with that water. It has to push it to the extremities. That can cause swelling in the extremities, and it can also cause headaches and migraines. Okay. So we really need to think about, well, how much are we really consuming per hour?
Right.
And right now, I think the consensus is, a liter or less per hour. Can you consume that throughout the day? Sure.
And so the effects are swelling, bloating?
Well, if you drink way too much, yeah. And then to address the issue of demineralized water, this again is one of these highly contested, controversial issues in the world of health management, which is, is it really good to drink demineralized water? And again, there was a World Health Organization paper that was published in 2004 indicating that there can be in health-related issues with a long-term consumption of demineralized water that's produced either through reverse osmosis or through distillation. And both of these technologies purify water, which has great importance because we're dealing right now with contaminants in our water supply that municipal water engineers never anticipated would even be there 60 years ago. So now we're detecting all kinds of pharmaceutical drug residues in our municipal water supply, all kinds of toxins from manufacturing processes. So it's not an issue of bad-mouthing reverse osmosis or distillation. It has its benefits. The problem is that they're so good at taking everything out of the water, they also take the good things out of the water, like calcium, magnesium, sodium, potassium. And if we're consuming that water, it's electrically hungry, and it's going to start trying to steal those minerals, from whatever it touches. And if we're consuming large amounts, it's going to take it from us. And what the World Health Organization document talks about is the long-term consumption causes demineralization in the human body, and it doesn't happen overnight. You're not going to turn into like Jabba the Hutt and just melt or turn into the thing. But over extended periods of years, it can cause or elevate risk factors for things like osteoporosis if you're not consuming significant amounts of calcium and bone-building minerals in the process. And another concern is that it might actually damage mucosal membranes as well. So a lot of that, it's not, the science is not really hard on that, but there's definitely concern. There have been enough studies to warrant it.
Okay. Other question I had for you was, we provide personal training here at Live. Is hydrogen-rich electrolyzed water something recommended for athletes then? Does it have a benefit to them or to people who are just training heavily?
Well, based on all the research that I've read, I think it has a benefit to everybody. And I think moderation is the key. And before we talk about the athletic side, I'd like to talk about the diabetic side.
Okay.
And because that's my realm of expertise, and just looking at the different options we have for diabetes management. And first and foremost, it's important for everyone to understand that diabetes is a global epidemic, and we often call it the silent epidemic because it doesn't receive nearly as much airplay or focus as it really should. It costs our nation $250 billion a year just to address diabetes and its complications, and that number is growing. I mean, we're dealing with adolescents that 20 years ago, it was unheard of for adolescents to be diabetic. And now 25% of American adolescents are diabetic type 2s. And we're not really sure what's causing all of that, but with common sense, we can look at just the standard American diet and say, gosh, look at the amount of sugar that's in this. Look at the amount of trans fatty acids that they're consuming, and we're allowing it to happen. But diabetes is also a gateway disease, and it contributes to accelerated development of cardiovascular disease, osteoporosis, neurological issues, cancer, the list goes on. And so really what a diabetic would encounter is what everybody else would encounter. They just do it a heck of a lot faster. Yeah. And they technically don't die from diabetes. They die from collateral damage to all of their peripheral organs through chronic oxidative stress. And this is what hydrogen really suppresses. And of course, with electrolyzed reduced water, hydrogen is the primary component that really suppresses this kind of oxidative fire in the human body. And it's not, I know a lot of physicians have concerns about antioxidants and people taking too many of them. And there's a concern about that too, because we do need oxidative processes happening inside the body for regular function. But it so happens that hydrogen, based on existing research, it's selective. It doesn't disrupt any of those vital oxidative processes that we have to have working. It's very selective. It only suppresses, I don't know how it knows this, but it only suppresses those that seem to be bad or have a negative influence on the body. And with the diabetic population, we know that if they're consuming between 1 and 2 liters per day, which is what we've done all the studies up to, and that's essentially 4 to 8 glasses, we know that it increases their insulin sensitivity. So that is a good thing because it reduces the amount of insulin that they need. That also reduces the cost of their insulin. Insulin is very costly. We know that, again, consuming 1 to 2 liters reduces their LDL cholesterol on average by 15%, and that's the bad cholesterol. It increases their HDL cholesterol, which is the good cholesterol, by 7 to 8%. HbA1c is a measure of their average blood glucose over the past 90 days. And we know that that stabilizes, and we're seeing average numbers of between 7 and 6 on HbA1c levels just by routine consumption of the water. Does that mean that it cures diabetes? No, not at all. But we have seen in cases of prediabetes, we can reverse prediabetes if they maintain a regimented diet and they're consuming electrolyzed reduced water on a routine basis. It can reverse that condition, which I think is really important because once you're diagnosed as being a diabetic in the United States, that stays on your medical record indefinitely. And it will constantly elevate your cost of insurance. So it's really important that we keep our biomarkers in check and never receive that diagnosis because it's going to be significantly more costly down the road. Now, with regard to athletics, we're seeing something very similar in that we also know that the hydrogen-rich water, because it functions as a very powerful antioxidant and has some degree of acid-alkaline suppression kind of capabilities in the athletic population, we're seeing that it actually reduces lactic acid accumulation. So that allows the muscles to run longer and stronger. Right. So instead of loading up on all kinds of protein and everything else, and again, there's only a limited amount of protein that we can process per day, and there are lots of bodybuilders and athletes that are consuming way more than they actually need, or their bodies can even handle, which can also be very dangerous to the kidneys. But with regard to water, we also know the athletes, they might be a little bit different because they are sweating and a lot of the water is evaporating out of their system. They might be able to consume a little bit more. But still, we need to fall within that kind of National Academies
range,
which is between 2.7 liters and 3.4 liters, unless they're just really sweating out. But in that case, they do need electrolytes and stuff too.
Okay. So I have a question. I went on a motorcycle trip this last weekend, and I brought as much electrolyzed water with me as I could. How long will the hydrogen gas stay in the water? Can you pack water for 2 weeks to go on a long camping type trip, or is it something that you have to keep like just over the course of a few days?
Yeah, that's a really good question too, and it's actually not very long lived. So this is why we have to have machinery to make it on a regular basis. And we know that hydrogen, it can be slightly stabilized in water for several hours. So after production, it will remain dissolved in solution for about 4 hours. And then after that, it begins off-gassing, or it begins evaporating. And we know from the laboratory studies that after about 24 hours, it's about half of what it is at saturation. And then after 48 hours, the water is back to equilibrium, which is basically a scientific term for saying all the gas is gone and it's lost a lot of its therapeutic value. Now, the water will remain slightly alkaline simply because it has charged particles of potassium, magnesium, and sodium. And that has a little bit of a health benefit to it. And so even if you boil it, those don't go away. The water will continue to remain alkaline. But if you boil the water, or if you heat the water up, the hydrogen is going to dissipate even faster. So it's really important to have fresh water on a routine basis.
Okay.
Now there are different ways of producing, hydrogen-rich water. And if you are on the road, there are hydrogen sticks that you can use, which use magnesium hydride to produce that. You can do the same thing with silica hydride or even calcium coral hydride. The drawback to these, though, is that you can't produce a wide variety of waters. And this is why at the university level, we actually use the electrolysis process. Because we can buy one machine and we can produce all kinds of cleaning and disinfecting waters along with cooking waters and everything else. So it's actually a much better cost-benefit ratio to do it electrically than it is through hydrolysis.
Okay.
But there are other options. So if you're on the road, that might be one. But what I'd actually recommend, I'm not sure if you have any travel cases on your bike, but when we do our clinical studies, we try to find insulated flasks like the steel flasks, and we'll pre-chill them. And you can make ice cubes out of the electrolyzed water and contain the hydrogen in the ice as long as you put it right in the freezer very quickly. And then you can just drop some of those after you pre-chill your container, drop those in there, and then fill it up with water, and then you're good, for your bike ride, so long as you're not going to be on the bike for more than a day or so.
Okay.
And it works very well.
So that makes me think of another question. When I ran out of the electrolyzed water, I had to pick up I got a Aquafina from the gas station, and the first drink I took of it, it made me feel thirsty. It felt like it washed away all the moisture out of my mouth and my throat. What is it that makes this hydrogen-rich water seem so much like smoother and just more hydrated?
Yeah, well, and that's a really good term, because that's the same term that I keep hearing from people as they begin consuming the water. And I have to tell you, I have the same experience. Having consumed the water for over 2 years, I can't go out and easily drink bottled water anymore. It tastes terrible to me. I can't drink tap water. I can taste the chlorine right away.
Yeah.
But there's an aspect of the water which is sometimes called microclustering. And this was a term that was used when they were doing magnetic resonance imaging in a research project maybe about 13 years ago. And I'm not really a fan of this term because it sounds a little spacey to me. In the laboratory environment, we might be able to get away with using it. I use the term reduced surface tension.
Okay.
And if you remember, you grew up in Oregon just like I did, and you remember the water skippers on the water.
Yeah.
They would slide across, and they're able to walk on water because there's this boundary at the top of the water which is like elastic, and nothing can penetrate it. So they can walk on it. What happens when the water is electrolyzed is that surface tension decreases. So the water can now penetrate membranes a lot easier than typical water can. And that doesn't last forever, but that's what happens when the water comes off of the cathodic electrode in the electrolytic water generator, otherwise known as a water generator. It does have reduced surface tension, and when you consume it, and this water also has hydrogen gas in it, when you consume it, it moves through your cellular membranes. It goes right through your intestinal lining much faster than standard water does. So translated, that means you're going to be super hydrated. It makes it right into your joints. And oftentimes, we're getting to that age where we're starting to not recover as fast as we used to. We might have a little bit of joint pain in the morning. We know that those who are 60 years of age and older generally battle this on a routine basis. And part of that has to do with they don't have the kind of synovial fluid in their joints that they used to. This water will make its way through the muscle tissue, through the joint tissue, and add an extra layer of hydration in those joints. So oftentimes they feel a lot better, and they don't need to take things like aspirin or painkillers like they used to.
Okay, good information. Thanks, Nate. That was Nate Darnell from Diabetes Support Services, and I'm Gabe Johansson with Live Nutritious Fitness. Thanks for joining us, and we'll see you next time.